Okay, so welcome to Data Analysis and Web Apps in R and RShiny. Thanks for joining us. My name is Lucas Powell. I'll be one of the co-teachers for this course, along with Karina. And we're really excited to share all these skills with you this week. Okay, so first, just a few housekeeping. I'm going to share my screen. Let's see if you can see. Let me know if you can see Ed. I'm not sure how many of you have accessed this page already, but this page is where all the class communication will be. I already put some discussion posts on the logistical information. Here are the materials for the week. I sent the link in the chat. I'll just quickly go through the logistical information in case you missed it. So we're going to be starting right at 6 p.m. every day, so please try to make it here on time. One of us is going to give a quick lesson on some concepts, and then right after we're going to split you up into breakout sessions for an optional session if you want to join us. I think it's going to be a lot of fun, so it'd be great if you could join us after that. Just some Zoom rules. So we'll be in this room the whole time, the whole week. Since there are quite a number of you in this class, we ask that you please ask all your questions through the Zoom public chat. And since there are two of us, while one of us is teaching, the other one will be helping answer questions throughout the lesson. And as we were just talking about, please download R and RStudio onto your computer. This is especially necessary if you are intending on participating in the optional workshops. It'd be really helpful if you have these set up. And then make sure to download these files. And now we're going to do quick introductions. So in the chat, please introduce yourself. Say your name, where you're from, and I guess a fun fact or why you're interested in this course or in data science or web apps. So I guess Karina and I will introduce ourselves quickly. I'm Lucas. I'm currently a rising sophomore at Harvard, intending on studying math and computer science. Yeah, Karina.
Hi everyone, my name is Karina. I'm also a rising sophomore at Harvard, probably studying applied math and computer science. Lucas and I have been spending this summer working on some R and RShiny apps for some of our Harvard math classes, and we're excited to teach this course to you guys.
Cool. And with that, I think we can get started.
Yeah, sounds good. All right. I will share my screen. For those of you just coming in or who may have missed part of Lucas's intro, we're going to be using RStudio. I'm going to demonstrate stuff on RStudio for this course. And if for some reason, so it'd be best if you could install RStudio, but if not, we do have a link to a website called Replit that is an online kind of code editor thing that will have all our code. And so if you get lost or have a Chromebook or for some reason unable to access RStudio, we do have all of our code there so that you can follow along. And in that vein, just in the interest of time and getting through everything, if you get lost on code, instead of like asking us to scroll back up, while we know you're well-intentioned, we do have all the code on that link. So just refer to that link. All right, so today we're going to just do kind of an intro to the R programming language, and we're just going to introduce some basic variables, data types, data structures, and just fundamentals of R, basically. So I have shared my screen. Hopefully everyone can see it. And right here, I have pulled up my RStudio application. And so if you open up RStudio, you should get something similar. And so I guess you have two options. We want to first create a file. And so to do that, you're going to go to this top bar and you're going to go File. If you want to create a new file, you say New File, RScript. And if you have a Mac, you can see that the shortcut is also Command-Shift-N. Otherwise, we did send you a template code file in the Drive folder. And so to open that up, you can just go to Open File and then go to whichever folder you have the file in and open it up. So in my case, I have it in this folder, but in your guys' cases, it's probably just in downloads or something. So just go ahead and open that up. And so this file just kind of contains kind of a lecture outline, just kind of a template for what we're going to be going over today, and kind of guides for where to put various elements of your code. So yeah, so the first kind of basic thing we're going to go over is just writing, like printing hello world, which is like a first step for most programming languages, tutorials, courses. And so in R, that's just going to be print hello world. And so by the way, I'm just going to kind of live type code. And if you guys could type along, if you want to interactively follow along, I'd highly recommend that. And again, if you get lost or fall behind, code is in the Replit link. And so what this does is it says print, which means, it means print. Basically, it's when you run it, it's going to show on this console right here. So it's just going to kind of print is just like show the user what's happening. And hello world is just a string or like a piece of text that we want to print. And so in R, we're going to enclose pieces of text with these double quotation marks. And so we say that, look, on our console, we have hello world. So that's just kind of basic ins and outs of like, operating RStudio. And so to run your code, as it says in the comments, you can hit Control-Enter if you're on a non-Mac, Command-Return if you're on a Mac, or just hit this run thing here to run like one line of code. So yeah, that's kind of a brief intro. Yeah, R is very similar to Python. They can do a lot of the like very similar things. And I don't know, it's kind of just like a matter of choice. R is considered like a statistical programming language, and it's more useful for like data science and statistics applications, which is a lot of what we're going to be going over. So yeah. All right, so transitioning into the next portion, we're going to introduce some basic data types. And so data is just like storing like stuff that's being stored in a program or a computer. And so there are a few different types of data, like there's numbers, there's text, there's true or false values called booleans, and so on. And so we're going to kind of introduce the concept of a variable. A variable is just a name for a value in programming. It's kind of like a variable in algebra, like x, y, z. If you say like x equals 1, like x is a variable. And so we can name variables anything we want. So normally they'll start with a letter. And I think, yeah, I would stay safe and just use letters and numbers. So we can say like test variable 1 equals 1. And so that's going to assign the value 1 to test variable 1. And then if we want to see what test variable 1 is, we can print it. And so if we run that, we see 1. Alternatively, we can also just call the value of test variable 1. This, I think, particularly works in RStudio, where you can just like call a value of a variable and it'll print it onto the console. So if I run that line, it's also just going to print 1. And something to point out here is that if some of you have programmed in like Java or JavaScript, you might remember that semicolons are required at the end of every line of code. In R, that is strictly not necessary, as seen in like line 8 here and line 16 here, but we can use semicolons to separate 2 lines of code on like 1 line of a file. So if we do this sort of thing, that's saying test variable 1 is 1, that's like 1 line of code, and then this on like a separate line, we have test variable 1. So that's just kind of a way, like if you want to save lines or something, depending on how you want to format your code, that's something you can do. We can also have strings like hello world or like hello or something. So we can say test variable 2 equals hello. Again, strings in R are going to be in double quotes. Then if we want to print that out, we can do that. And that prints hello. And then we also have a primitive data type, like a basic data type called the Boolean, which is basically true or like a value denoting true or false. So if we have like true, that just means like, yeah, that just means true. And so if we run that, we get true. And then, so that's called a Boolean. And the opposite of true is false in all caps. So yeah, those are kind of 3 data types. Now here is where variables in coding kind of differ from variables in math. It's 2 things. I guess one basic thing is that you can change the value of a variable. And so for example, you can say, let's say test variable 3. Let's change it to 2. And the values changed. So we can't really do that in math, right? Like we can't just say like, oh, x equals 1, but now it equals 2. But in programming, we can totally do that because variables are just ways to store data. And so if we want to store something else, all we have to do is just redo the assignment. And we can change not only the value of the variable, but also the type. So we have 2 kind of nice operations called as character and as numeric. So as character takes in a number and changes it into a string. So for example, we have test variable 3 is equal to as character variable 1. We print that out. Test variable 1 was 1, right? And so if we change that into a character, now it's 1, but with quotes around it. So it's not the number 1 anymore, but rather the string of text with the character 1. And then to kind of reverse that, we can also do as numeric, which takes in a string and turns it into a number if it can be turned into a number. So if it contains like A, B, C, D, it's gonna like give you an error. But if you have like 1, 2, 3, then it'll turn it into like 123. So to demonstrate that, we can say test variable 4 equals as numeric just reversing that right back. And that gives us 1 again without the quotation marks, which means that it's no longer a string of text, but rather a number. Yeah, so it is the same concept as casting in other languages. Casting is just changing between variable types. So yeah, nice catch. So yeah, those are some of the different variable types. And I guess wanted to show you guys another functionality of string that's going to be kind of important in the apps that we're going to program later. which is that we can put strings together, like we can add numbers or like add fractions or something. And that's what the function called paste. So let's say my name is Karina. You can put your name or like anyone's name here. Just name it name. And then let's have a greeting. Let's say greeting equals, actually, yeah. So for our greeting, we're going to have some sort of greeting and name. And so this paste function, what it does is it basically puts those strings together and separates them with a space. And so if we print the greeting, so run all 3 lines, it says, hello, my name is Karina. Just puts those strings together. So that's kind of a nifty thing to note. And then I guess just to be complete, so we've seen how to concatenate or like put strings together. Just for like completeness sake, we can also like add numbers. Like R is like a calculator basically. So if we do 1 plus 2, we get 3. If we do 3 times 8, we get 3 times 8, and then 3 over 4. We get like the exact fraction, and then so those are just like the basic numerical arithmetic operations, just to have that in the back of your minds. Yeah, it is all in a link. If you check the ed page that Lucas linked earlier, it should be in the Google Drive folder. There's like a doc called Day 1 Replit link, I think. So yeah, that is basic data types and variables. So now that we have kind of an idea of basic ways to store like the most elementary units of data, we're going to move to something called data structures, which is kind of structures or like buildings or like factories or like, I don't know, like, yeah, structures that store multiple pieces of data in kind of an organized way. And so in R, what we love is this thing called vectors. So if you click this run button, it'll run the line you're currently on. But if you highlight an entire section and click run, it'll run that entire section. So you can also like run the entire document by just highlighting the entire document. So vectors are basically, I don't want to say they're lists, but they're basically lists, but they're called vectors. It's basically like a column of values that can be like anything, and they're created using this function called C, which stands for column. So let's just create an example vector. Let's call it vector example because we're super creative. And it's just going to be the numbers 1 through 5. So 1, 2, 3, 4, 5. And if we print that, we get a nice list of numbers. So yeah, that's just like basic vector. We can also combine vectors or like grow them by adding them to each other. Like we can add numbers, we can add strings, we can also add vectors. And we do that again with the C function, which is kind of nice. So let's create something called a combine vector. So we're going to combine the vector example we just created with, let's say, 10, 11, 12. And so R is smart enough to know that like we don't want that whole vector as like one element, but we want to like split it out into 5 elements. So the whole thing is like an 8 element vector. And so as you can see in the console, we have 1, 2, 3, 4, 5, 10, 11, 12 as desired. We can also, if the vector consists of numbers, we can also calculate sums and stuff. And so, for example, we say sum, which is an R function example, that gives us 15, which is 1 plus 2 plus 3 plus 4 plus 5. And right there, you see how vectors can be useful, because otherwise, like if you had like just variables separately, have to call plus on every single one of them, but if you combine them all into a vector, all you have to do is say sum, and boom, it's there. So that just saves you a lot of code, and just makes things more organized. Now let's just, for fun, we can create like 2 more vectors, and I'm gonna demonstrate some other operations on these vectors. So let's say v1 is 2, 3, 4. v2 is 6, 7, 8, 9. So we're gonna run these. As we can see, just printed those vectors right there. And by the way, it's just good practice, like if you want to see what's going on in your code, to just like a variable in the same line, just print it out. Actually doesn't hurt, and it's just easier to catch bugs and see what's wrong, if anything, with your code. So we have these 2 vectors, and what we can do is something called like element-wise or component-wise operation. So each element of a vector, so like each thing in a vector, can also be called like a component in math terms. And so when we call our standard arithmetic operations, they're going to act component-wise. So what do I mean by that? What I mean is if we do v1 plus v2, that's going to take every element of v1 and add the corresponding element v2 to it. So it's going to return a 4-element vector where each element is the sum of those elements in the original 2 vectors. So if we run that, we get 1 plus 6 is 7, 2 plus 7 is 9, 3 plus 8 is 11, and 4 plus 9 is 13. Likewise, we can do the same thing with multiplication. We run that, we get 1 times 6 is 6, 2 times 7 is 14, 3 times 8 is 24, and 4 times 9 is 36. So that's what happens when you do arithmetic operations on vectors. So yeah, so vectors are actually, as Lucas said, in higher math, like college level math and linear algebra. But for now, it's enough to just think of them as like data structures, like ways to store information in R. Yeah. So that's vectors. Now we're going to, so we've gone from numbers or like single variables to vectors. Now we're going to add another dimension and go to something called matrices, which is basically rectangles of numbers, or like vectors of vectors. It's basically just like one level up. And so there are a couple ways to construct matrices from vectors, namely cbind and rbind. So what that means is column bind and row bind. So if we say cbind v1, v2, what that do is treat v2 as columns. So it's going to create a matrix that's 2 columns and 4 rows. So if we print that out, we have our, here, let me make this bigger. So we have 2 columns and 4 rows. The kind of, I don't want to say opposite, but like kind of opposite way we can do it is rbind, which stands for row bind, where it's going to treat each of these vectors as rows. And so it's going to make a 2-row, 4-column matrix. So if we run that, we get the exact opposite, or what we call in math transpose of what we had earlier. And so depending on what kind of data you want, or like how you want to access your data, one of these might be more useful than the other. But yeah, this is just to show that there are multiple, or like 2 ways to combine vectors into a matrix. And just as a note, we can definitely like create more like matrices with more rows. All we have to do is, like, if we had a vector named like v3, we can just keep going, and as long as these vectors all exist and match up, like if they're all the same length, this will work. And so yeah, we can just combine any number of vectors by column or row. So that's one way to create a matrix from vectors. What we can also do is create a matrix in another way. So first we're gonna create some inputs. So let's say C, V1, V2. So what that's going to do is it's going to take V1 and concatenate it to V2. So it's going to create like one 8-element vector. And now you might be like, well, okay, we just flattened it. How are we going to like yeet it back into shape? That is where R is kind of cool. So R can basically take an n-element list and like reshape it into an like X by Y matrix as long as X times Y equals the number of elements in that vector. So we're going to call this thing matrix example, and the function we call is called matrix. And so the first argument is matrix inputs, which is just like the list of things. The second thing we want to put in is n row, which is the number of rows we want. And then we want n col, which is number of columns. So 2 by 4, just 2 rows, 4 columns, because we have 8 elements. And we're going to say I row equals true. And I'll just kind of demonstrate like what that means. So if we print that out, we have 1, 2, 3, 4, 6, 7, 8, 9. And then let's see what happens if we do by row equals false. So what by row equals false does is it basically kind of just shuffles the elements in kind of different order. And so like by row means it'll like go through the whole thing and like fill up one row after the other. And if it's not by row, it'll do something a little like weird, like it'll go like by column. So it'll go like first column is 1, 2, then it's 3, 4, and so on. So it's just 2 different ways to fill up a matrix using the matrix function. Yeah, so that's how to construct a matrix. And now something else we might want to do is access elements in a matrix, which is like getting specific entries. And so the way we do that is through something called indexing, which is where we like reference the place that an entry is at in a matrix and get the value at that place. So one thing we can do is get a single element of a matrix. So what this does is it gets the element in the first row and the third column of the matrix. So I'm going to just run this again to make sure we're on the same page. So we have this matrix, and then if we get first row, third column, that's this first row, third column right there. The other thing we can do is get entire rows or entire columns. So for example, we can say matrix example 1, comma. So again, like it's row, comma, column. So if we leave off the column entry, we just get that entire row. So we get the entire row. And then we can also do a similar thing to get an entire column. So if we say comma 3, so again, it's row, comma, column. So if we leave off the row, we just get the whole column. We get 3, 8, which is our third column there. That's how we access things in a matrix. And for those of you who have programmed in Python or Java or JavaScript, you might remember that we start indexing in those languages at 0, which means like the first element is actually like index 0. But in R, we start indexing at 1, which like makes a lot more sense to normal people. And basically, like what you see is what you get. So row 1 is the first row, row 3 is the third row. You don't have to like offset anything by anything. So yeah, that's one of the good things about R. It's much more intuitive in some ways, like this way. Okay, so that's accessing elements in a matrix. Now, another thing that's going to be useful in data analysis is naming your rows and columns. Like if we have like a 2D table, we might want to call the rows and columns different things, like day 1, day 2, day 3, or like weather, wind, rain, like anything. So the way we do that is through these functions called row names and col names. So row names names the rows. So what we do is pass in the matrix that we want to name, and then we pass in a vector of names. So for example, we can say row 1, row 2. Since our matrix has 2 rows, we can pass in a 2-column, 2-element vector. You can name it anything you want. You can name it like chocolate and vanilla or like whatever. And so if we print out matrix example now, what we have is instead of the indices, they're replaced by row names. Similar thing we can do is with the col names. So col name stands for column names, and it's the exact same thing. We pass in, this time though, a vector that has the same number of elements as the number of columns. So let's say column 1, column 2, column 3, column 4. Feel free to get more creative. These are just our basic names. And so if we do that now, we see that our like numerical indices have been replaced with the much more interesting strings or like much more descriptive column names. And the beauty of this is that now we don't really have to remember like which number column an entry is at. And like as you get like bigger and bigger data sets, it gets harder to remember like whether something is at column 3 or column 4. But if you name the columns, it's much easier to remember like, oh, that was in the snow column and that was in the sleet column or whatever. And so we can reference or access these things using the row and column names. So if we say row 1, comma, col 3, that's the same thing as the 1, 3 that we had earlier. So it's just the row named row 1 and the col named col 3, which corresponds in this case to the first row and the third column. And we can also do a similar thing as we did before, where we get an entire row or an entire column. So this gets the entire first row, and to get an entire column, we can say like col 3, the comma in front of it, and that gets the whole thing. And I just think that's kind of more intuitive and easier to remember if you like label your rows and columns, just because like it's easy to get them switched sometimes. And this just makes it super clear, like, oh, if you say row 1, comma, nothing else, that literally gets you all of row 1, and same with columns. So that is matrices. Pause for a second. Yeah, cool. All right. The third type of data structure that we wanted to touch on is lists. This is why I was kind of hesitant about calling vectors like lists of things, because there's a concept called list that is like a totally kind of separate data structure. It's like similar, but like in terms of semantics and implementation, it's kind of different. Like it's a different concept. So the way we create lists is usually we start with vectors and then literally like cast them as lists. So just to start, you can create some vectors. Let's say line 1, just like 1, 2, 3, 4, 5. And then let's create another one, which is like C, like A, B. By the way, as you guys have noticed with like the row names, the column names, and now line 2, vectors can contain any type of element. Like it doesn't just have to be numbers. It can also be strings, booleans, anything. The only case where it has to contain a certain type of thing is if you're doing an operation on it. Like if you want to call sum or product, then everything has to be the type, like everything has to fit whatever that operation specified. But otherwise, vectors can have anything. So let's just go ahead and run those. And now we're going to combine those into a list. And the way we do that is just name a list. You can name it anything you want. And we're going to call the function list. And let's see what happens when we print that out. So what this does is it creates a list of 2 things. So not 8 things, not 5 plus 3, but 2 things. And each element, like the first thing is the first vector and the second thing is the second vector. And so from here, you guys can kind of see the difference between a vector and a list. Like in a vector, when we said, when we like combine vectors, when we said like the second vector is C of the first vector and 10, 11, 12, that treated the first vector as like 5 different things or however many things were in that vector. So like the whole thing was 8 elements. But in this case, list treats each element as its own element. So it doesn't do any flattening. And so each element is literally just what is passed in. So that's kind of the utility of a list. The way you access lists is similar to the way you access things in matrices, except you're going to want double brackets. So for example, if you have list example and you want like the second thing, you're going to go double bracket and then go 2 for second. So that gives you ABC. And just if you guys want to see item 1, it's that 1, 2, 3, 4, 5 vector there. So that's lists. Similar to vectors and matrices, we can also name stuff in lists. So for example, so what we do is we call the function names, pass in the list we want to name, and we pass in a vector of exactly like the number of elements in the vector is exactly the number of things in the list. So we can say first line, second line, then we can print. So again, similar to matrices, it just replaces the item number with the item name. And a little different from matrices, we reference the name a little differently. We use something called, we use this thing called the $sign. So for example, if we want the second line element, we go list example, $sign, second line. And as you guys can see, when it printed here, it also shows the $sign instead of like the quotation marks that it had for matrices. So if we do that, we get ABC. If you guys want to try first line, you should get 1, 2, 3, 4, 5. So yeah, that's lists. All right. So that's like basic data structures. And now I'm just going to kind of go over some programming kind of logic fundamentals. So one of the fundamental concepts in programming is conditionals. So far, what we've run is just like stuff that's always true. Like we say, like we print this, like this vector equals this, no matter what. But what if like we take some sort of user input or like weather conditions change or like there are a bunch of factors that we want our code to depend on and we want to run different things based on what those factors are. That's where conditionals come in. Conditionals are, you can kind of tell from the word that's like based on certain conditions. And so you guys might have heard of this in other programming languages. It's like the concept of if statements and else if statements. And so the way we do that is using this sort of syntax. So if you guys want to delete the hashtags, which are hashtags, by the way, represent comments, which are just like things for humans that humans can read. If you guys want to delete those and put in some like thing, we can do that. So for example, if we say like if 2 is less than 3, then print 2 is less than 3. If we run this, it'll print 2 is less than 3 because 2 is less than 3. Now, to show you an example of how it doesn't work if our condition is not satisfied, it doesn't print anything. So yeah, because 2 is not more than 3. So that's like basic conditionals. Actually, I'll show you guys one more thing. And so what if we like don't want to just stop there? Like what if we want to do something else in case the statement is false? Well, the other thing we can do is else, which means like if the above is not true, print something went wrong. Why is this doing? There we go. Might have to like skip. What? Okay, that's weird. If
They might have to be in the same line.
there we go. Now it prints something went wrong. So yeah, good point, Lucas. The else does have to be on the same line as like the closing bracket of a brace of if. So that's just like a thing to take note of. But yeah, that's basic conditional logic. I'll leave it uncommented. So that's if else. The other thing we can do in code is something called loops. Sometimes we like don't know how many times we're going to run something, or like we run it like 10 or 20 times and we don't want to like type the same code like 20 times. And so what we can do is just type it once and say, for I in like do this 20 times. And so kind of unpacking that. Something we can do in R is create a vector that's like a sequence of numbers. So if we say 1 to 5, that gives us a vector of elements from 1 to 5. And if we say 1:6, that gives us a vector of elements from 1 to 6. So that's just kind of a neat thing we can do. And so what we can do is, let's say we want to print all the numbers from 1 through 5. You can say for I in 1 to 5, print I. And so what that does is it's going to print 1 through 5. So that's just like for loops. We can also do other stuff that like doesn't have to depend on I. Like I can just specify like number of times we want to do something. So if we say print hello world 5 times, print hello world 5 times. That's for loops. There's another type of loop called the while loop, which is like do something while something is true. I guess I can show a quick example of that. So let's set a variable like n equals 5, and let's say while n is positive, print n is positive, and we decrease n once, like in every iteration of the loop. So that prints it 5 times because it goes 5, 4, 3, 2, 1. And so an important thing with while loops is that you need to make sure to update your condition. Otherwise, you're going to get an infinite loop. Like if we start at 5 and then we like never do this thing, it's just going to keep going forever because n stays at 5. So you want to make sure you have condition that you update that can eventually be violated or reached, or depending on how you structure your loop. So that's loops. The last thing I wanted to go over is functions. So functions, you guys might have heard of them in math class. And so in math class, they explain them as like, f of x equals like some formula for x, like ax plus b or something. In code, we can kind of expand that definition. It doesn't just have to like map numbers to numbers, but basically functions are shorthands for mapping inputs, doing some stuff, and then giving an output. So an analogy I like to give is, let's say I told you to take a bite of the pasta. What does that mean? Well, that means you pick up your fork or chopsticks or utensil, put it into the bowl or dish of pasta, wrap the pasta around your utensil, lift it up from the bowl or the dish, put it in your mouth, release the utensil, chew it up, and swallow it. But I don't tell you to, hey, pick up your fork, put it in the pasta, swirl it up, lift it up to your mouth, and swallow it. I just tell you to take a bite of the pasta, and you know that that's what that means. And it's much easier for me to just say, take a bite of the pasta, rather than like all of those steps. And so in this case, take a bite of the pasta is kind of like a function. It's just like you define it once, and then you kind of know that it means a certain thing. And so it's like So a function is basically like a code word or like a code name for a series of steps that you don't want to call like 5,000 times. So yeah, that's a function. And basically you take in an input, do a bunch of stuff, do whatever you want, and then you have an output. So the function syntax is as outlined in these comments. Is basically, yeah, you just give it a name and then call the function on it. Ironically, the word function is a function, so just keep that in mind. So let's create a function called greet. And we're going to say it's a function. It takes in a variable called name. And so we're going to create a variable within this function called message. And we're going to use that paste function that we learned earlier. And we're going to say, hello, my name is name. And so it's just going to basically print out what we did earlier. We're just putting it into a function. And then what we're going to do is return message. And so return is the code word for output. So that's basically saying like whatever is inside the parentheses is going to be our output. And so it's just going to return our message, I guess. And so now we can just call it much more easily, and we can call it multiple times. So let's say we'd like greet multiple people. And so you guys can see how that's like much easier. First of all, like the call to the function is a lot shorter. And second of all, if we hadn't had that function, we would have to like write this code like 20,000 times for every person we want to greet. In this case, we can just say, hey, greet them. So to run this function, just do, first we run it and then call it. And yeah, so in this case, our input is name. And name is like only known within the context of the function. So if we have like, if we put name like outside the function, like it won't know what we're talking about. It's just like a variable whose scope is within the function. And same with message, like message outside of this greet function makes no sense, but it knows that like within the purposes of this function, message is that like pasted, concatenated message. So yeah, that is functions. So I guess that's all for like our fundamentals. I guess I'll take a few minutes for questions and then go into workshops.
Okay, great. Yeah, thanks so much, Karina. I guess if there's nothing else to say publicly to the whole group, now I'm going to stop the recording, and we're going to move on to the next part of the class.